Have you ever noticed how continents like South America and Africa look like they could fit together, almost like pieces of a giant jigsaw puzzle? It's a fascinating observation that has intrigued scientists and explorers for centuries. That's no accident. It's a clue to one of Earth's most powerful and revolutionary ideas, plate tectonics. This theory has completely transformed our understanding of the planet's past, present, and future. The ground beneath us isn't a single solid ball of rock. Instead, it's made up of several massive sections or plates that fit together like a cracked eggshell. These plates are in constant, though incredibly slow motion, shifting, colliding, and pulling apart over millions of years. This movement is so gradual that we don't notice it day to day, but over time it shapes the very face of our world. Plate tectonics is the science of how Earth's outer shell is built and shaped by these giant moving slabs called plates. Their boundaries are where the action happens, where continents split, oceans open, and mountains rise. This concept explains the origins of earthquakes, the fiery eruptions of volcanoes, the towering heights of mountain ranges, and even the mysterious depths of the ocean trenches. The plates are like colossal rafts floating on a sea of hotter, softer rock below, called the mantle. This churning, semi-molten layer acts almost like a conveyor belt, slowly moving the plates above. Understanding plate tectonics gives us a backstage pass to how our planet really works. It helps scientists predict natural disasters, find valuable resources, and unravel the mysteries of Earth's history. It's a story of constant creation and destruction, a relentless dance of rock and fire, where new land is born and old landscapes are forever changed. So let's explore this incredible geologic ballet, written in the very rocks beneath our feet. Every mountain, valley, and ocean tells a chapter of this ongoing saga. The story of plate tectonics is still unfolding every day, shaping the world we know and revealing the dynamic, ever-changing nature of our living planet. To understand plate tectonics, picture Earth as a giant peach. The thin, delicate skin is the crust, the juicy, thick flesh is the mantle, and the hard pit at the center is the core. This simple fruit gives us a surprisingly good model for our planet's structure, helping us visualize the layers that make up the world beneath our feet. The real action takes place in the outermost shell, known as the lithosphere. This layer includes both the crust and the very top part of the mantle, forming a rigid shell that wraps around the entire planet. But the lithosphere isn't a single unbroken piece. Instead, it's fractured into massive slabs called tectonic plates, which fit together like the pieces of a gigantic, ever-shifting jigsaw puzzle. There are about a dozen major plates along with several smaller ones. Each plate carries with it entire continents, vast stretches of ocean floor or sometimes both, drifting slowly atop the softer, more fluid layer beneath. These plates are the true puzzle pieces of our planet, constantly in motion. They drift, collide, and slide past one another, sometimes at rates as slow as a few centimeters per year, about as fast as your fingernails grow. The boundaries where these plates meet are where the most dramatic events on Earth occur. Here, the immense forces of nature are unleashed, giving rise to earthquakes that shake the ground, volcanoes that erupt with molten rock, and mountain ranges that slowly rise skyward. In fact, most of the world's geologic drama, its most powerful and awe-inspiring events, unfolds along these seams, where plates interact in a never-ending dance. So don't imagine Earth as a smooth, unbroken globe. Instead, picture a vibrant mosaic of interlocking, moving pieces, each one shaping the world in its own way. Every continent, every ocean, and every island you see on a map is riding atop one of these restless plates, carried along on their slow but relentless journey. These plates are the fundamental building blocks of our planet's surface, shaping the landforms and features that define our world. Over millions of years, the plates have traveled vast distances, carrying continents across the globe, opening and closing oceans, and creating new landscapes in a slow-motion epic that continues to this day. This ongoing movement is responsible for the ever-changing face of our planet, shaping everything we see on the surface, from towering mountains to deep ocean trenches. Plate tectonics is a truly planetary-scale phenomenon, a dynamic process that has sculpted Earth for billions of years and will continue to do so far into the future. What makes these giant plates move? The answer lies deep beneath our feet in the hidden layers of our planet, where powerful forces are always at work. It's all about heat and physics. The Earth's interior is incredibly hot, and this heat is constantly trying to escape to the surface, driving a cycle of movement that never truly stops. Beneath the lithosphere is the asthenosphere, a hot, soft layer that flows slowly like thick honey. This layer isn't liquid, but it's not solid either. It's just soft enough to let the rigid plates above it glide, ever so slowly. Heat from Earth's core creates convection currents in the asthenosphere, moving the plates above like a conveyor belt. These currents rise and fall, carrying energy and material and setting the plates in motion. The plates creep along at just a few centimeters per year, about as fast as your fingernails grow. It's a pace so slow, we'd never notice it in a single lifetime, but over eons it adds up to incredible change. Over millions of years, this slow movement shifts continents thousands of kilometers. Oceans open and close, mountains rise and erode, and the face of the Earth is completely transformed. Plates move in different directions, some collide, some pull apart, and some grind past each other. Each type of movement creates its own dramatic effect on the landscape. When plates slide past each other, they create faults, fractures in the Earth's crust that can unleash powerful earthquakes. The way they interact at their boundaries creates Earth's diverse landscapes. From the tallest mountains to the deepest ocean trenches, every feature tells a story of moving plates. The energy from these movements is immense, building mountains and triggering earthquakes and volcanoes. Sometimes this energy is released suddenly, with dramatic and sometimes devastating results. This slow-motion dance is the ultimate source of Earth's most powerful phenomena. It's a process that shapes the planet's surface, atmosphere, and even its climate over time. It's a silent, patient, but unstoppable force. Even when the world above seems calm, the plates below are always on the move, quietly sculpting the world we see. The plates' movement is the engine of our ever-changing planet. Without it, Earth would be a static, lifeless world, lacking the dynamic beauty we know. Every landscape is shaped by this relentless process. The canyons, cliffs, and coastlines we admire are all products of this ancient, ongoing motion. Plate tectonics is the story of Earth's constant transformation. It's a tale written in stone, told over millions of years and still unfolding today. It's the force behind the world we know, a never-ending dance that continues to shape our planet's past, present, and future. When massive plates grind against each other, things get rough, literally. Their jagged edges lock together, building up strain like a wound-up spring. Eventually, the strain is too much, and the rocks snap, releasing energy as seismic waves. That's an earthquake. The break happens deep underground at the focus. The epicenter is the point above it on the surface. Most earthquakes happen along plate boundaries, like California's San Andreas Fault, or Japan's complex plate intersections. These regions are always under stress, ready to release energy in a quake. Earthquakes aren't random. They're a direct result of plate tectonics. They're the planet's way of letting off steam from the relentless grind of its plates. While destructive, earthquakes are a fundamental part of how our dynamic planet works. They remind us the ground beneath us is always moving. Volcanoes, like earthquakes, are spectacular results of plate tectonics. Most volcanoes are found along plate boundaries, especially in the Pacific's Ring of Fire. At divergent boundaries, plates pull apart, letting magma rise and create new crust, like along the Mid-Atlantic Ridge. At convergent boundaries, one plate dives beneath another, melting and forming magma that erupts as volcanoes, like in the Andes. Volcanoes are Earth's plumbing, bringing deep material to the surface and recycling the crust. They're not just beautiful and dangerous, they're vital to shaping our planet. Every eruption is part of the ongoing cycle of creation and destruction. Mountains are built by the immense power of plate tectonics. When two continental plates collide, neither wants to sink, so the crust crumples and pushes upward. This is how the Himalayas formed, and they're still rising today as the Indian plate pushes into Asia. The process, called orogeny, is slow but relentless. Older ranges like the Appalachians are remnants of ancient collisions. Volcanic mountains like the Andes form at subduction zones. But the tallest, grandest ranges come from continent-to-continent collisions. Mountains are the planet's crumple zones, evidence of the slow, powerful dance of the plates. Every peak is a testament to Earth's restless energy. Plate tectonics doesn't just build mountains, it also pulls the crust apart. At divergent boundaries, the crust stretches, cracks, and forms rift valleys, like the East African Rift. If the stretching continues, the crust breaks, magma fills the gap, and a new ocean basin forms. The Red Sea is a young ocean, slowly widening as Africa and Arabia drift apart. This process, repeated over millions of years, created all our major oceans. The Atlantic Ocean began when Pangaea split, and new crust formed along the mid-Atlantic ridge. The deep ocean floor is actually the youngest part of Earth's crust. Divergent boundaries are where new land is born. Plate tectonics is a cycle of building up and breaking apart. The landscape is always changing. The map of our world is always changing thanks to the dance of the plates. Over geologic time, continents have drifted, collided, and split apart. Supercontinents like Pangaea formed and broke up, reshaping oceans and land. Evidence for this includes the puzzle-like fit of continents and identical fossils found on distant shores. Today, continents are still on the move. America drifts away from Europe, India pushes into Asia, and Australia heads north. In the future, the map will look completely different. Oceans will widen, mountains will rise, and new land will form. This constant motion affects climate, life, and the very shape of our planet. Plate tectonics is the engine behind Earth's ever-changing geography. The story of our world is one of endless transformation. Why does plate tectonics matter? It's the key to understanding our planet. It explains why we have continents, oceans, mountains, volcanoes, and earthquakes. Knowing where plates meet helps us predict hazards and build safer cities. Plate tectonics guides geologists to valuable resources like minerals, oil, and gas. It even helps regulate Earth's climate, acting as a planetary thermostat. The movement of plates has kept Earth habitable for billions of years. Studying plate tectonics connects us to the deep rhythms of geologic time. It reveals the immense forces shaping our world, past, present, and future. Understanding this dance is essential to understanding our home. Plate tectonics is the story of Earth itself.